to rationalize the denominator, what does that mean? We've had questions before where we have like a square root or something in the answer, or in this case, it's the number I, right? The imaginary number. And these numbers are irrational, and kind of like saying ain't in English class would be kind of looked at really funny. They'd be like, what are you doing? This is English class. You should know not to do that. Or using like improper grammar. This is kind of a grammar of mathematics, if you will. You typically do not leave irrational numbers like I in the denominator. So what we have to do is we have to use something called the conjugate, which is actually really just the number 1, but it's a well-chosen number 1. You might hear the phrase well-chosen 1. So anything over itself is equal to 1, right? Mm-hmm. Like x over x or x plus 2 over x plus 2. It doesn't really matter how you word it. Anything over its identical self is equal to the number 1. So that's still the case here. But I've chosen a very convenient one because it happens to be the same thing as the denominator, but the only thing that's changed is the operator is different, right? And over here it's a minus and over here it's a plus. With me so far?
Yeah.
All right. So what that's going to do for us is when we go to multiply these out, just like this example we had back here, I'm going to actually copy and paste this because it's so relevant. Copy, paste this. So if we remember that we have, I'm going to zoom in here. If we remember that a plus b times a minus b is equal to a squared minus the b squared, then we can look at this and say, oh, a minus b times a plus b. Right?
Yeah.
Should be able to transpose this. So in fact, 4 minus I times 4 plus I is equal to 16 minus I squared. Do you remember what I squared is equal to?
Is it equal to 1?
You're very close. It's negative 1. Because remember how I is the square root of negative 1?
Yeah.
So then if we square I, we ought to get whatever's under that radical.
Okay, yeah, I remember that.
So this is very...
something with that.
Yeah. So you got it. This is very important because now, remember, this is in the denominator. And we're trying to get rid of the I altogether. So when we square it, when we end up with this I squared term, it's really just equal to negative 1. So then we can just write 16 minus negative 1, which is equal to what?
Oh, okay, yeah, 17.
17, yeah. So that's our denominator. And it doesn't really matter what's in the numerator, just, as usual. You can have, like root 2 over 2, right? As long as that denominator is a rational real number, then we can leave whatever kind of nonsense we want in the numerator, and it's acceptable. The numerator for this would be equal to these two terms multiplied together, which let's just do that real quick just for completing the question. We have, what was it, negative 1 times 3i, or negative 1 plus 3i times 4 plus I. So if we multiply this out, help me out here, Ty.
Negative 4.
All right.
Negative I. Oh, my bad. I thought we were going under that.
Negative I, that's fine.
Negative I. 12i. And then 3i squared.
3i squared, very good. And then, so if we're grouping some like terms, we've got negative 4, and then what are these going to group to?
11i.
11i. And then what's this going to work out to?
Negative 3.
Negative 3, very good. And then we can actually combine these two here, right?
Yes. Just negative 7.
So negative 7 plus 11i ends up as the numerator. So then your answer to this question, so then our answer just becomes obviously numerator over denominator. So negative 7 plus 11i over 17. All right, so that is called rationalizing the denominator. Something that you have to do kind of sort of as needed, but it comes up on SAT. And again, this is one of those things that is obscure enough to where we tend to forget it. But when you end up with one, or like on an ACT question, like one of the really harder ones, multiple choice type scenario, where if you can at least imagine what a rationalized term would be in the denominator, you can use this to eliminate some answer choices.